All right. So if I'm graphing a quadratic, what is the highest power that I'm looking at? What's a quadratic? Do you remember? It's not 4. Huh? All right. What type of equations are we talking about in this chapter? Okay, great. What is a quadratic?
It's like
that's the quadratic formula. We're getting there. Maybe this is too easy.
find something.
I have x squared plus 8x is 10. Nod your head if that's a quadratic.
Yes.
Yes. If I have x to the third minus x squared plus x minus 14, is that a quadratic?
No.
No. What do you think it is?
If you got
Nate, what is a quadratic?
ax squared plus bx plus c equals 0.
Spectacular. All right. So we have standard form of a quadratic. I knew we'd get there. Ax squared plus bx plus c equals 0. This is what we're looking at in this chapter, and we've done all sorts of different things with it. We factored it. We completed the square with it. We solved that by completing the square, and out came the quadratic formula. So this is what we've been looking at. This is not a very good form in terms of being useful. So the standard form, just like the standard form of a line, is not very helpful. But the factored form is very helpful. Because if I have it factored, who can tell me what the roots of that quadratic are, just by looking at it? Yeah. Good. P and Q, right? The root is, what do I put in to get out 0? Well, if things multiply to 0, I have to set that equal to 0, and then the second piece equal to 0, and I get my roots are P and Q. Okay. All of these things look like this. All right? So it's important that you label your information clearly when we do this. If you just draw U's all over the paper, that doesn't help me, okay? So what's important is the points. And we already talked about, we have this line of symmetry which goes down the middle, which means that if we reflect it, it would be the same on both sides. And we're going to use that information to come up with our graphs. So really what we're going to use is 2 points, this one, the roots, and then this third point, which down here, which is called the vertex. So there's my line of symmetry. Speed this up. And the distance is the same on both sides, just like we saw on the warm-up problems. That's called the vertex. So that is the lowest point, or it could be something else. What else could it be? The highest point. If I flip this thing over, it's either my maximum or my minimum value, and when you guys get to calculus, you're going to spend way too much time worrying about that. Okay? So that maximum and minimum of these curves become important. They call it the vertex. So if I'm solving it, if I want my roots, remember the roots are where it crosses the x-axis. Those are going to be important. So at those 3 points, the roots and the vertex, we can always sketch a graph of the quadratic. All right, we could also go back and do it how we did it back in 6th grade and make a table and get all of our points that way. But we're going to be a little bit more sophisticated and use the roots and the vertex to get the graph. All right. Still with me? Good. All right. If I look at this parabola, all right, I know a couple of things. By looking at it, could somebody tell me what the roots are? I know it's a little bit small. 2 and negative 3. So those are my roots. And if I wanted the equation, what would the equation be? In factored form. X minus 2, x plus 3. So the equation is x plus 3. X minus 2, right? Because if I put in negative 3, that becomes 0. If I put in 2, that becomes 0. All right. I forget what I said next. Where's the line of symmetry? How'd you get that? Negative 1.5.
Because it's 5. Well, I just added the 2 and the 3 together. Like, forget the minus, and I got 5. And then divide it by 2.
Yeah.
2.5. Then move 2.5 over either one.
Good.
You get it.
All right. So did you everybody follow that? Okay. Let me see if I can recreate it. You figured out the distance between the roots, which was 5.
Yeah.
And then you took half of that. All right? Because the line of symmetry is in the middle. and that's 2.5. And then you said I could add 2.5 to either one of those roots, and I get negative 1.5. So what does that look like as an equation? I can't just write negative 1.5. I need an x or a y. Which is it? Is it y equals negative 1.5 or x equals negative 1.5? X, right? These are all the values where x is negative 1.5. Y negative 1.5 would be a horizontal line. All right? So there's my line of symmetry. And just like Nate went through it, I add my distances and I get negative 0.5. Okay? We good? All right. Now, we're really looking at the average distance between the roots. That's what we're looking. We figured out the distance. We divided by 2. We add it to one of them. It's not always going to be so simple, because what if I gave you not the factored form, but the standard form, and past that, what if I gave you a standard form that didn't factor easily? Okay? So this is pretty straightforward. Even this is pretty straightforward because you could factor it, find the roots, and back solve it and go from there. What we really want to look at is there a relationship between A, B, and C that we can pull out that would give us a general equation for the line of symmetry? That's kind of what our goal is. So if I'm looking for the general equation, and this is where it gets complicated, so hopefully our brains are all warmed up. How do I find the roots to this general equation? Only there was a formula. There is a quadratic formula. All right. So if I have that, I know that that is the roots, right? Okay. So that, how many roots does this give me?
Possibly 2.
Possibly 2, right? At most 2, the plus and the minus. So if I was to do the same thing instead of with nice numbers, but do it with this scary equation, and average them and find the distance between, basically find the distance halfway between them, I'm going to figure out the line of symmetry. Do we agree? All right. So we're taking the general case. I want to know, I have 2 roots. Where's the middle? So there's my 2 roots. Root number 1 is the positive. Root number 2 is the negative. Right? And then we do the same thing that Nate did. We're going to average, get the halfway point. So I take half of both of them added together. What's nice about these is they already have a common denominator, right? And when I add them together, I have a plus b squared minus 4ac and a minus root b squared minus 4ac. What's going to happen with that? Go away. And I'm going to have negative b plus another negative b. How many negative b's is that? 2. So it comes down and simplifies right away to negative 1 half, negative 2b over 2a. I can simplify that into negative b over 2a. So this is going to be my line of symmetry. So that's pretty simple. And if we go back, so x equals negative b over 2a. It's going to be my line of symmetry. Let's see if we can do this. If we look at this case, b was 1. Negative b over 2 is negative 1 half. So it's the same thing that we did before. We just did it for the general case. And now we have a very simple equation to find the line of symmetry. So if I gave you something, oh, I don't want to do that yet. Sorry. If I gave you something like this, who can tell me where the line of symmetry of that parabola is going to be? Sorry, it's equal y.
Negative 2.5.
Yeah, how'd you get that?
Negative b is negative 5, and then 2 times 1.
Yep. So I'm going to get negative 5 halves, and negative 2.5 is going to be my line of symmetry. Alright, so once I have my equation in standard form, I can find my line of symmetry, we can find it with the roots, we can go from there. So let's look at an example here, because we're missing something. All right. Here's my parabola. And I know it's maybe a little bit hard for you guys to see it. Those are my roots. Okay? Who can tell me what the equation is going to be for that parabola? Yep. Mumble. Good. All right, so our equation is... Yeah, do we agree? Okay. So let's run through it and let's try to find the coordinates of this vertex. Okay? So if I was to put it in standard form, it looks like that. I just foiled it out. And then where's my line of symmetry going to be? What's my b value?
12.
Negative 12. And then, so I take half of that, and then the opposite of it. So it should be at 6. Let's see, does that make sense? Here's 5, there's 6. That seems like it runs through there. So that's good. So it should be x equals 6. And then if I wanted to figure out this y value, how could I do that? So this is the line where x is 6, and I have this equation, and I want to know y. I want to know the coordinates of that vertex. What do I need to do?
X equals 0.
Well, x equals 0 is...
Put x equals a 6.
I put x equals a 6 where? In the equation, right? This graph is the picture of solutions to this equation. So if you have an x value, you plug it in, and you get a y value. Yeah? All right. So if I do that... All right, that was our line of symmetry. Blah, 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 blah. And we want to find the vertex. So I plug it in, and I get out negative 9. Yeah? We good? We're not good. Why are we not good?
Oh, did you plug in the x coordinate?
Well, where's negative 9 on my graph?
Below.
It's down there. This is up 9. So what happened?
You have it as negative 9?
What's that?
You have it as negative
I have it as negative 9. So what I have is if this thing was flipped over, it was down there and going up. Anybody know what we missed? It was the first thing that we did. So we found the roots, and then we made the equation, but we missed something in the equation. Yeah. We need to make this minus. We need to flip it. We need to invert it. So if I have a u that goes down, like a hill, then it's going to have a negative sign on it. All right? If I distribute that through, it changes this value to be negative. It changes this to be negative. That becomes positive. My line of symmetry is still the same. And now if I plug in 6, I get 9. So it works.
So you get this from x equals 6?
X equals 6. What I get, yeah, if I plug in, the line of symmetry is the same.
Yeah.
All right? I get x equals 6, and I plug it in. But if I plugged it into the first one we had, I get out negative 9.
Yeah.
Because in general, graphs of quadratics go up. If I want it to go the other way, I multiply it by a negative to flip it over.
So,
And that's what we missed.
could we just, if we got negative 9, could we just say that's 9, or should we?
Probably. You could probably, if you got the right number but the wrong sign on it, you have it flipped. But in general, if you have to know, if I just gave you the roots, let's just say I didn't give you the picture, and I just gave you, where was it? This, 3 and 9, you wouldn't know whether it went up or down.
Yeah.
So you either have to have the equation. If I give you this equation and this is negative, it goes down. If I give you the graph and you see that it goes down, you have to have a minus on it. We're going to get a lot of practice with it next week, but I wanted to show an example that's a little bit trickier so that you're kind of clued into, it's not just the same thing. I need to think about what's happening with these negatives. You're going to do a lot of graphs of these next week. All right. So that's correct. I want you to try a couple. So I want you to sketch a graph of that. Oops. Let's see if I did it right here. So You could do it without factoring it out or foiling it out. You could plot the roots and see the distance and go from there. But you could also notice that b is negative 4, and so my line of symmetry, I plot my roots, negative 1 and 5, and my line of symmetry is the opposite of b over 2a, which becomes 4 over 2, which is 2. And if you just think about it, that makes sense. This whole thing is 6, half of that is 3. I go over 3, I'm at 2. All right, so there's my line of symmetry. There's my 2 points. I need to find the vertex. How do I find the vertex?
Plug 2 in for x.
I know the vertex is on this line. It's the only point of the parabola on this line, so I plug in 2 for x. I see what I get out for y. And I get out negative 9, I think. And so I put that point on there. And now I can connect the dots, and I have some sort of accuracy to my picture. And so the question was, how do I know that it goes up? Well, I could have just figured out where the vertex is, and then I know it goes up. Or I can look at there's no negative in front of it, and these x's, if I was to FOIL it out, gives me a positive x squared. So we're going to find on Monday when we do a graphing calculator exploration that this part here, that number, the coefficient in front of the x squared, is what dictates whether it goes up or down. But if you don't want to worry about that and you trust yourself to find the vertex, you can always find the vertex. If the vertex was 9, I would have known it would have gone down. All right, thumbs up, sideways, or down on that. We're feeling okay?